Alright, one of the Great Pyramids, before it eroded, had a base of 230 degrees, or 230 feet. It had angles of 52 degrees. And so we want to figure out what the original slant height was and the original height. And so when we think about slant height, in today's terms, that would be the hypotenuse, right? Okay. We need to kind of pull out some of our geometry. Okay. For one, this side, this height, is shared between these two triangles, right? So one, I know that this triangle, this angle is congruent to this angle. I know that this angle is congruent to this angle because they're both perpendicular. Right? And I also know that this side is congruent to itself, right? Reflexive property. Remember that? So I have angle, angle, side. So that tells me that these two triangles are congruent. Okay? So I know what this angle would be, right? If I wanted to figure it out. Okay? But that's not what it's asking us. But the most important thing here is that I know that this has to be a bisector. Okay? These have to be congruent. That's the most important thing. So now I know that this side of this triangle, this right triangle, right? That's the only thing we know how to work with right now. You're going to be able to work with non-right triangles, but right now that's all you can work with. Okay? So this right triangle is congruent, so that means 230 divided by 2 is equal to whatever this side is. Okay? And so that's going to be 1 and 1 with 1 left over and 5. So that's 115 and 115. Does that make sense? Okay? Cool. Alright, so now I want to figure out what the height of this triangle is. Okay? Or the side or something, right? Now I'm going to use SOH to figure it out. I have a degree. I have theta, right? Theta is 52 degrees. Okay? So if I think about it, which one do you want to figure out first? You want height or slant height? It's really up to you. The first one was height, so we might as well go with height, right? So part A was height, so let's go with height. Okay, I want to know this guy. I don't know what this is. Unknown. Okay? So, I'm going to give it a variable. What variable you want to use? A or T or H? H? Okay, H. Alright, so I know that I have a theta, and now I need to know what else I have. So is this hypotenuse? Is this adjacent? Or is this opposite? Adjacent, good. So I know that this is adjacent to theta. What I'm looking for is across from theta, which means it is the opposite. Okay, so this is opposite. So I have adjacent and opposite. So what am I going to use? So, Ca, or Toa? And why? Toa. Toa, yeah. I have O and A. Right? Well, I don't really have O yet, but I'm trying to find O through A. Right? So what I want is, I got this, I got O, and I got A. Okay, so I'm looking for the tangent of theta is equal to the opposite of 52 degrees is equal to the opposite, which is h, over the adjacent, which is 115. So I would just multiply both sides by 115. And I get h is equal to 115 times the tangent of 52 degrees. And if I use my calculator, I can figure that out. Right? As long as it's in degrees. And this is when it's really important to get your calculator in degrees. At the bottom of the calculator, it'll say degree. Okay? Alright. And so, I'm going to put in, see if I can do this. I'm going to put in tangent of, actually, let's put in 115 times the tangent of 52. 147.19. Now it's set to the nearest meter. So 147.19. But to the nearest meter means h is equal to 147. Let's see if I got that right. I did. That's always good. Alright. Next is the slant height. Now, you're going to use a lot to figure out the slant height. Right? But we can do the same thing, or you can actually use a squared plus b squared equals c squared, right? We have a squared, we have a, we have b, right? But it's kind of easy doing this, isn't it? Plugging this is calculator work. As long as I know how to plug it in. What's the slant? It's the hypotenuse, right? So I have theta, and I have either one. I know the adjacent, and I know the hypotenuse. AH, or I'm looking for the hypotenuse. Right? So that's So I'm going to be cosine theta is equal to the adjacent over the hypotenuse. Okay? Now this one's a little bit more funky. Okay? Cosine of 52 degrees is now equal to the adjacent, which is 115, over the hypotenuse, which we don't know, right? So in this case, we got to give it a letter. We can call it S for slant height. So S, right? Now, here's the thing though. How do I solve for this? Because S is on the bottom. Now I have a trick. Okay? How do I make my tricks? I use what I know to figure out what I don't know. Alright? I know that 1/2 is equal to 3/6. Right? I know that, right? So if I flip these, is 2 over 1 equal to 6 over 3? Does that work? Is that the same? Then that means I can flip these. That means that I can pretend like that's over 1 and then flip them. So I got 1 over cosine 52 degrees is equal to S over 115. And now it's just a matter of multiplying both sides by 115. So S is equal to 115 divided by cosine 52. Okay? And then I plug that into my calculator. So I have 115 divided by cosine 52. And that is 186.79. The closest meter, 186.79 would be 187. 187. All right, so